This is a video about the properties of real numbers. So, commutative property of addition and multiplication, associative property of addition and multiplication, additive identity, additive inverse, multiplicative identity, multiplicative inverse, and multiplicative property of zero. So we use a lot of these when we are evaluating or solving equations. So first I'll talk about the commutative property. So commutative property says that if we swap the order, if we have one operation and we swap the order of the numbers when we do that operation, that's going to be the same thing no matter what. So there's only two properties that works with, and that's addition and multiplication. So like for addition, if I say 3 plus 4, that's going to be the same thing as 4 plus 3. So I swapped the order. So 4 comes first, then 3. Same operation, and it's going to be the same thing. It's 7 for both of them. Now, if we did this for subtraction, it would not work. 3 minus 4 is not the same thing as 4 minus 3. So that's why we don't have a commutative property of subtraction, because it doesn't exist. It doesn't work. So when you swap the order when you're adding, that's commutative because you're swapping order, and property of addition because you're adding. Now, don't let parentheses fool you, because if I say something like 3 plus 4 plus 1 equals 4 plus 1 plus 3, all I did was swap 3 and the quantity 4 plus 1. So I put the quantity 4 plus 1 first and then 3. So just because it has parentheses doesn't mean it's always associative. So watch for that. So it's when the physical position of the numbers switch that will be commutative. So that's commutative. Learn how to spell it, please. You need to know how to spell it. It's not commutative, it's commutative. For property of multiplication, it's the same idea. So 3 times 4 is equal to 4 times 3. The physical position of the numbers has changed. The operation has not, and it is still the same thing. Again, watch out for parentheses. So if I say 3 times the quantity 4 plus 1, that's the same thing as saying the quantity 4 plus 1 times 3. And that's a commutative property because I swapped the order. Instead of the 3 first, I put the 4 plus 1, quantity 4 plus 1 first. So those are all examples of the commutative property of multiplication and the commutative property of addition. And remember, we want to use these properties when you're trying to evaluate to make things easier. So say that we are trying to multiply 3 times 7 times 5 times 1/3. Well, doing it in that order is not very easy, because by order of operations, you're supposed to do 3 times 7, which is 21, times 5, which is kind of difficult, and then times that by 1/3. That's taking a lot of time to do. But if we use the commutative property of multiplication, that says that I can take that and swap the order. So I'm going to write 3 times 1/3, then times 7 times 5, because I know that 3 times 1/3 is just 1. So that makes it a lot simpler for me to multiply. So the fact that I can take this and write this, and it's the same exact thing, is the commutative property of multiplication. So if you were working this out and you went from that line to this line, the property you showed would be commutative property of multiplication. And I don't want you abbreviating like that. Write out commutative, write out multiplication, or mult, M-U-L-T. And so that would be one of your steps. And then when you do 3 times 1/3, we know that that's multiplicative inverse. Again, I'm just abbreviating for the sake of the video. And then when you keep going, you're supposed to go left to right. So if I do 1 times 7, that's 7 times 5. 1 times 7, I'm multiplying by 1, it doesn't change. So that's multiplicative identity this time. And then to do 7 times 5 equal to 35 is just substitution. So that's how you use commutative property to help make multiplying or even adding easier when you're evaluating. So that's the commutative property of addition and multiplication. The next properties we're talking about are the associative properties of addition and multiplication again. So these are very similar to the commutative property, except this time the position of the numbers doesn't actually change. It's the order in which we do them. So for commutative, we swap them so that when we go from left to right, we do what operations we want in whatever order, because we actually switch the numbers. For associative, we don't switch the order of the numbers, rather we switch the order in which we do the operations. So the place where the numbers are doesn't change, just the parentheses. And we know by order of operations we're supposed to do what's in parentheses first. And that's why we use them. So we can see that we have 4, 5, and 2 being added. And on the right side of the equation, the position of the 4, 5, and 2 did not change. The only thing that changed was the parentheses. Instead of doing 5 plus 2 first, I want to do 4 plus 5 first. I can do that with addition. I can't do it with subtraction, and I can't do it with division. So that's why there's only 2, and it's of addition and multiplication. Those are our two special operations. So when the parentheses simply move, the position of the actual numbers does not. That is associative. So that's associative property of addition because it involves adding. But we also have the associative property of multiplication. So we could say 5 times 3 times 2 is equal to not 2. Remember the same numbers. 5 times 3 times 2. So on the left side of the equation, I'm choosing to do 5 times 3 first, indicated by parentheses. And on the right side, I'm choosing to do 3 times 2 first, indicated by the parentheses. So the position of the actual numbers did not change. We still have 5, 3, 2 on both sides, all multiplication. Only thing that changed was my parentheses. So this is the associative property of multiplication because I'm multiplying. Now I can try to trick you and do something like this. If I do 5 times 2, let's say plus x, let's throw a variable in there, times 4, so do something like that, equals 5 times 2 plus x, 2 plus x, not 2x, 2 plus x times 4. That, again, is associative because all I did was switch my parentheses. And it's kind of more obvious here that something else is involved because we've got our brackets. So the brackets moved, but the position of the three quantities didn't. We have 5, 2 plus x, and 4. 5, 2 plus x, and 4. So that, only thing that changed was those brackets, which we know we would go in brackets first, and then we'd have to do this. But since we can't do that, we go to distributive property. But either way, only thing that changed was where my parentheses were, not the actual position of the numbers. So that would be the associative property of multiplication. And just be careful. Remember, when you are looking for what property is used, you're looking for what changed. So I could say something like 3 plus 2 times 5 times 7 minus 3, and then have on the other side of the equal sign 3 plus 2 times 5 times 7 minus 3. And what you have to ask is what changed. So from this side to this side, I can see that my parentheses were first around 2 and 5. Now they're around 5 and 7. The 3 stayed the same. The minus 3 stayed the same. And the position of the numbers stayed the same. The only thing that changed were my parentheses. So this is associative property. And since it's multiplying where it happened, so right here is multiplying, it's the associative property of multiplication. It doesn't matter that there's addition and subtraction out here because that's not what changed. What changed was when I was multiplying. So it doesn't have to just be the simplest example to be associative property. So when I move those parentheses, not the actual position of the numbers, that is the associative property. If it happens when you're adding, the parentheses around adding, that's addition, and parentheses around the multiplication parts, that would be multiplication. Next to additive identity and additive inverse. Remember that the additive identity is 0 because that is the number when you add it to anything, it will not change its value. So additive identity is the fact that a number plus 0 will just stay that number. So if we have a simplification problem where I have 5 plus 0 plus 7, in my next line I put 5 plus 7, the property that was used was not substitution because it's special. It's more special than that. It is the additive identity property because I added 0 and it did not change the number. Now we can also have variables in there, so you could say 0 plus a equals a. That's also additive identity and stuff like that. Even if it was 5 minus 0, that would be additive identity because you're adding a negative 0, and 0 doesn't really have a sign, so it doesn't matter. It's not neither negative nor positive. For additive inverse, this is an operation that gets us back to the additive identity. So when I have a number plus another number, that gives me 0, the additive identity. So when my result is the additive identity, that is the property of that is additive inverse. So additive inverse is when I get a result that is the additive identity. So when you get 0, that's additive inverse. And remember, it doesn't actually have to be adding. It can be subtracting because subtraction is just adding a negative. So if I said 5 minus 5 equals 0, that is also the additive inverse property because you can think of this as adding a negative. So anytime you get 0, that's additive inverse. Anytime you add 0 to something, that's additive identity. And again, this will happen a lot. You'll have this property when you're evaluating. The next two are just like the last two, except we're dealing with a different number. What number, when you multiply it by it, doesn't change the value of that number, and that number is 1. So 1 is the multiplicative identity. So when you multiply by 1, so 5 times 1 equals 5, we know that it doesn't change the original number being 5. Times it by 1 does nothing to it, so that property is the multiplicative identity property. When you multiply by that number and it doesn't change it. So multiplicative inverse is when you get back to the multiplicative identity. So when your result is the multiplicative identity, that property is multiplicative inverse. So 5 times 1/5 equals 1. Because I got back to the multiplicative identity, that property is multiplicative inverse. So when you times by 1, that's multiplicative identity. When you multiply to get 1, that's multiplicative inverse. Because those two numbers, in order to multiply to get 1, had to be multiplicative inverses of each other, or another word, reciprocals of each other. And again, this will happen a lot when you're evaluating, but don't let it trick you. If you have a times 2/5 equal to 1, that's a multiplicative inverse property because I got 1, and that means that a must have equaled the multiplicative inverse of this number, which is 5/2. So very similar for both multiplicative inverse and additive inverse. You're trying to get back to 1, get back to 0. And multiplicative identity and additive identity, you are multiplying by 1 or adding 0, which both don't change the number, so that's why it's called the identity. It doesn't change. Last one is the multiplicative property of 0, the fact that any number times 0 is 0. So anytime your result is 0 from multiplying, then you had to multiply by 0. So if I said 5 times x equals 0, that's an example of the multiplicative property of 0 and helps you realize that x has to be 0. Because the result of multiplying two numbers, if the result is 0, one of those numbers has to be 0. Since 5 is not 0, x must be 0. And so that's an example of the multiplicative property of 0. So overall, for your multiplicative and additive identities here, when you multiply by 1 or get 1, when you add 0 or get 0, those are going to be special properties most of the time. If you get one from subtracting, that's not special. If you get one from multiplying, that's special. For a 0, no matter what, if you get it from adding or multiplying, it's going to be special. And again, if you add or subtract to get 1, that's not special. But if you multiply to get 1, it is special. When you multiply by 1, it's special. And when you add 0 or multiply 0, that's a special property. So don't just write substitution for all of those. And that's it for this video.